Today we are going to finish chapter 7 and then review Wednesday, and we are going to take the third exam Friday. The third exam will cover only chapter 7. Yeah, when I check the second exam, then we finish chapter 6. So this coming exam number 3 will cover only chapter 7. Last Friday, I emailed you my summary. Did you get my summary? Right, the table, the big table, 6 topics, right? Yeah. You know, even when you go to the Blackboard, the lecture notes, at the bottom, as already I posted all summaries. The summary, chapter 6 and 7 here, then you can see this one. Yeah, you know, I modify the table, right? So I made 3 by 2, right? It looks like that. Already I emailed you my summary, but it's very exactly same as this. It's 1, 2, 3, 1, 2, and 3, right? Yeah, here. Today we are going to discuss the last one. It's 1, 2, 3, 1, 2, 3, right? So we are going to have 6 kinds of the confidence intervals. Simply, I can give you the 6 problems. As not only 6 problems, is additionally, I will add more, but it's basically the 6 problems. And in the exam, I do not give you anything, right? Yeah. So you have to read the problem is carefully, and you have to figure out is 1 sample or 2 sample. It is for the mean or proportion, the sigma and sigmas using the z-score, and S1, 2, t-score. Any kind of proportion, always we use the z. Today, we are going to use the z-score again, right? Yeah. So you have to figure out is how many means, how many sigmas, S's, right? Yeah, it's case by case, and you can choose one. Good, right? Okay. So when I go to the homework, let me go to the Cengage homeworks. Just a second. Let me get into section number 4. Yep, look at this. It's number 18. That is for this one, number 18, right? Tonight, Monday. 19, already I posted the homework number 19 today, right? 2 proportions, due Wednesday. And already I reopened number 14, 15, 16, 17. I think it's most of you got already good scores in 14, 15, 17, 16. It's better than 90, better than 95. Even you don't have to try to. Only some of you missed or lower score. Yeah, please make them up before the exam Friday. Okay? But if you got good scores, never mind. Yeah, here's another review. Here's another review homeworks, right? So please, as a complete 18 tonight, 19 due Wednesday, and the review homeworks is before the exam Friday. So when I go to the review homeworks, it has 9 questions. Let me select randomly number 4. Can you see the mean? Can you see the sigma? Can you see the S, the sample standard deviations? What does it mean? Proportion. Okay, now, how many proportions? 1. That is. Do you have an idea? Right? Let me go up to number 3. Can you see the mean? Yes. Let's go. Can you see sigma? Can you see S? Yes. How many? How many S's? How many X bars? Only 1. Only 1 mean with the S. We need a T-score, right? So that is the indicators. That is the indicators. Let me jump to 8. Can you see the mean? No mean? Sigma? No sigma? How about the S? No S? Again, proportions. 1 proportion or 2 proportions? 2 proportions. Today's topic, right? Yeah. So please remember, we have 6 kinds of confidence intervals, right? When you read the problem carefully, you pick one, then apply. Yeah. In this exam. Or in the review homeworks, right? Yeah. So remember, yeah, we have 6 combinations, the 6 kinds of the confidence intervals, and the third exam is based on only the chapter 7, the 6th one, right? Yeah. So do you have any question about the exam Friday? Yes.
So it's only going to be 6 problems?
No, I told you. Basically 6 problems, but I can ask you more. Yeah, more or less. Yeah, I will tell you again Wednesday. Yeah, Wednesday we are going to review again, right? Yeah, so I will tell you about more. It's more about the exam Wednesday, but basically it's basically 6. Basically 6 topics. Probably I remember in the exam I suggested that you can prepare your summary. You can bring my summary. You must bring the Z table and the T table, right? Yeah. So, and calculator. Okay. Yeah. So if you have any other question, please. Any question now? And other question? Yeah, please ask me. It's Wednesday, right? So I opened, posted all homeworks, right? Yeah. From number 14 to 19. 19 is the today's one. That will be the last one. And additionally, I posted the review homeworks from chapter 7 for the exam number 2, Friday. Okay, then let me finish chapter 7. Yes, here. Today, we are going to discuss the last confidence interval for the proportion difference. You know, sometimes, yeah, we must check the assumptions. It's n times p, n times q, another n times p, n times q. They are all must be bigger than 5, right? But I didn't check yet. I didn't check at all because we need a confidence interval. The other way, if that is less than 5, we cannot make the confidence interval. We need another application, right? Don't worry about that. We are not going to discuss the other applications, right? Yeah, in this course. So always it's bigger than 5 and bigger than 5. Yeah, even we don't have to check. Always it's bigger than 5 and bigger than 5, right? Yeah. So we don't have to take care of it, right? But if not, then we have to apply is another. Yeah. You know, this one is a very first statistic, right? Statistics. So yeah, we have more other applications. But anyway, here is the confidence interval for the proportion difference. Yeah, again, we need the P1 hat minus the P2 hat. Here is the P1 hat minus P2 hat. It is the point estimate always. Yeah, at the beginning, we need the point estimate. And then plus and minus margin of error. Plus and minus the second part, we need the margin of error. It will be the z-score, then P1 hat, one hat, and 1 plus P2 hat, Q2 hat over N1 and 2. Yeah, it will be the confidence interval here. Okay, good. I want to compare to this one. It was P hat, Z, P hat, Q hat over N. I mean this one. When we have only one proportion. So here's the one proportion, but here is the proportion difference. Z-score, Z-score. And here's the PQN, PQN. But 1, 1, 1. The other PQ hat, PQN 2, 2, 2. Difference? Difference? We edit. It's the same thing. It is the same as here. Same as the here and there, right? Yeah, it's always the point estimate is must be difference, subtraction, but here is the addition inside of the square root. Yeah, it's the same idea. Okay. So today we are going to discuss the last confidence interval for the proportion difference. And always the proportions, yeah, we are using the z-score. Good, right? Do you have an idea? Okay. Please look at this problem. During the normal sleep, there is known as the REM. Have you ever heard the REM before? The REM sleep. Yeah. Right, you know, the very beginning of your sleeping is not quite deeper, right? But yeah, we are dreaming and the eyes is moving, right? Yeah. So it's 90 minutes, it's at the beginning, right? During the REM sleep and using the electronic equivalent for the sleep lab, okay, good, possible detect REM things. Okay, it's fine, yeah. It's a study of the sleeping, right? And what? What is the experiment? The experiment is suppose it's two groups, it's separated two groups of the subject, is people randomly, right? And group number one is before going to sleep, they spend 1 hour watching the film. Oh my God, it's good, right? It's a comedy movie, right? Are you watching the movie before going to sleep? No. I'm watching YouTube, you know, it's before, yeah, it's almost the same thing. Then the first group has 175. It's out of 175, 49 dreams, feeling of the that many people, right? Second group has 180, but 63 of them dreams, feeling, and anxiety, fears, and blah blah blah, right? Yeah. So now, I'm sorry, it's a typo. It's a 95%. Let me take the 0.5% is it does not make sense. Yeah, I need the 95% is a confidence interval for the proportion difference. So let me take the P1 hat, the other one P2 hat. So the first one must be 49 out of 175. And the other one must be 63 out of 180. We need the two proportions. So let me take the fraction. It's a 49 out of 175. Here is the 0.28. And the other one will be 63 out of 180. then the second one will be 0.35. What was the confidence interval? P1 hat minus P2 hat plus and minus. We are going to take the z-score. P1 hat, Q1 hat over N1 plus P2 hat, Q2 hat, N2. So now then, apply the statistics. Let me take the interpretations later on the second page. Okay, now then, 95% confidence interval. Good. So here must be 0.28 minus 0.35 plus and minus. Do you remember how much was the z-score for 95%? You know, one way I suggest to you, even you can take the z-score from the t-table, right? So if you have a t-table, please look at the t-table. 95%. From the bottom, you can see the z-score. How much? 1.960. Yes, it must be 1.960. And then now 0.28 times 0.72 out of 175. How did I get 0.72? You know the 0.72 must be the Q. How did you get the Q? Subtract the P from 1. 1 minus the P, right? The other one is 1 minus 0.28. That would be the Q, 0.72. Same idea. The second one must be is a 0.35. How much will be the Q then? 65. 0.65. Sample size 180. So let me plug statistics into the formula. Then now let me take the inside of the square root. .28 times 0.72 over 175 plus 0.35 and 65 over 180. Inside of the square root, I have 0.0024. Now, let me take the E, the margin of error. 1.96 times square root of 0.0024. Then I have 0.096. How much will be the proportion difference? 0.28 minus 0.35. Here is the negative 0.07. Can it be negative? Proportion? See, it is not a proportion. Who is this? Proportion difference. The difference can be negative. You know the proportions never ever negative, right? But it is not the proportion, but the proportion difference. The difference can be negative. Yes, why not? So now then, from the subtraction to the addition, right? So negative 0.7 minus 0.096. That is the negative 0.166. When I take the sum, it will be 0.026. Who is this? It is 95% confidence interval for the proportion difference. Yeah, simply, yeah, we figured out, yep, it is the formula. And yeah, simply just plug into statistics into the formula, take the confidence interval. Right? You know the proportion difference. Sometimes it's negative, sometimes it's positive. When do we have a negative difference? If the second one is bigger, if the second proportion is bigger than the first one, we can take a negative difference. When we have a positive difference, the first one is bigger than the second one, then we have a positive. Sometimes negative, sometimes it's positive. What does that mean? Watching movie, it doesn't work. Yeah, you don't have to. You don't have to watch the comedy movie or the dreams, anxiety, fears. Yeah, it doesn't work because sometimes like this, sometimes like that, right? So it's almost the same thing. Yeah, there's no difference. So that is the 95% is confidence interval. The other way I can interpret, I am 95% confident as usual. It's a 95% confident. The proportion difference is between negative and positive, almost zero, right? It's almost the same. I finished the 6 kinds of the confidence intervals, right? So do you have any question? Do you have any questions from the homework? Yeah, again, number 18 to 19, the new one, yeah, from today. And the review, which one? 18? Okay. Okay, let me go to number 18. For tonight, it has only 2 problems. Let me look at the number 1, because the number 1 and number 2 is exactly the same. I will try number 2. You want to try number 2? Yeah, I will try number 2. In number 1 has the 3 groups, 1, 2, 3, right? But please look at part A. Find the 95% confidence interval between 1 and 2. For the difference between 1 and 2. Part B, another difference between 1 and 3. And the next one, another difference between 2 and 3. Pairwise. Yeah, even though we have 3 groups, 1, 2, 3, but 95% confidence interval for the mean difference between 1 and 2, between 1 and 3. That is the reason why I pick only 2 questions. It has a 3 and 3 and 3, 6, right? Yeah, so I just take the 2, right? And let me look at the number 2, the second problem. Yeah, it's the same thing. The 3 groups, number 1, 2, 3, 85% is the third one will be 85% again. The mean difference between 1 and 2, another mean difference between 1 and 3. What do you say the next one? Between 2 and 3, right? Yeah. And means, right? Yeah, here means, right? Yeah. And how many means? 1 and 2. 2 means, right? Do we have a sigma? Yeah, is it here? Do we have a sigma or S? We have a S's. It's a 2 S's, 1 and 2. 2 S's, 1 and 3, 2 S's. So we have to apply this one. Does it make sense, right? Yeah. So I want to try second problem. So let me. Yep, it is enough. Let me copy and paste. Yeah, it's the same thing. Number 1, number 2 is the same thing. Both of them, we have to apply what? We have to apply the formula x1 bar minus x2 bar plus n minus t score, because we have s's, s1 square over n1 plus s2 square over n2. So let me apply the very first one. Between 1 and 2, let me see. AD 9.2 minus AD 5.7. 1 and 2. 1 and 2, right? Let me take the t-score later from the t-table. And then plug 3.04 square over 15. And the second one, 3.64 square over 15. Yep, I need the first one and the second one. Now the problem is who will be the t-score, the critical value. 85%. Now please look at your t-table. 85%, 0.85. How many degree of freedom? 14 and 14. Actually we have to take the smaller one, but 14, 14, same. 14. Yeah, give me the t-score. 85% and the degree of freedom, 14. 1.5, 23. Is it right? Yeah. Good, right? Okay, let me take the mean difference. Let me take the mean 85.2 minus 85.7, 3.5, the mean difference. Let me take the multiplication with the critical value later. Let me take the inside of the square root, 3.04 squared. Just a second. Oh, yes. Over 15 and 3.64 square over 15. Now, inside of the square root, I have 1.499 and 4. Let me take the E part, the margin of error. E is now then 1.523, the t-score, times the square root of 1.4994. Here is the 1.865. And now the mean difference, 3.5 minus 1.565. I have a 1.635. How many decimals? 3 decimals, right? It's good. So let me take 1.635 to, let me take the sum. 5.365. Let me check. Let me check the answers. 1.635 to 5.365. Yeah. Good. Good, right? Do you have an idea? Let me set up. Yeah, I don't want. Yes.
Can you do part D?
Okay, I will later. Let me set up. It's not give you the answer, but let me set up the part B, 1 and 3. 89.2 minus 81.5. 85. I expect 85% and 14 again. I expect we are going to use the same t-score, 1.523, and now 1 and 3. So 3.04 square over 15 again. But now the third one is a 3.77 square over 15. Can you set up? Right? Yeah. So you can take the other one. Okay, then now let me check the others. Part D, comment. I have no idea. Because I need 3 confidence intervals, right?
Yeah.
But let me see. The 3 confidence intervals were for 95%, 85% confidence interval for the mean difference. So basically, I can interpret we are 85% confident the mean difference will be inside between this one, right? Yeah. So what would be the good interpretation? What would be the good comment? There is the 85% probability with the 85% confidence. I think I like this statement, right? It's better than it's similar, but always we interpret it. We are 85% confident, right? So I like this better. It's the same. It's the same thing. Difference between the mean test or the between the population mean test. That is a difference, right? Which one is better? Look at this. We want to do the test for the population, or we want to do the test for the sample?
Population.
Thank you. What was the title? The title was confidence interval for not p hat. It was p1 minus p2. Who are the p's? Population proportions. Let me go to the previous one. Last week, we discussed confidence interval, not x bars. Mu1 minus mu2. Who are the mu's? Population means, right? Always we want to estimate the population thing. So I think I like this. Let me check. Nobody knows. Yes, yes. Remember, we wanna estimate, we wanna take the confidence interval for the population. But we don't know anything. So because of that, we take statistics, sample means, sample standard deviations, and the sample size, make the confidence interval. But for whom? Population mean difference, right? That is. And how about the second part? Okay, now, there is a hint, right? There is a hint. At the 85% confidence level, what can you say about the ability difference? Yeah, we have to compare between 6 to 8 hours and 3 to 5 hours, right? Yeah, I got only one confidence interval, right? So please take the other confidence intervals, then compare them, right? So I think I cannot tell you what will be the answer. But I have many trials. Let me select one. Wow, I'm lucky. Yeah, that is. Yeah, I don't know. Yeah, I'm so lucky. I just take the first one. Oh, let me try the second one maybe.
No.
Yeah. No more. Yeah. So you can compare. Two confidence intervals, right? Yeah. So you can compare them. Yeah, that is. Yeah. But this one is the in general interpretation of the confidence. Yes, what?
Can you I don't know, make up some random confidence intervals and tell us how to compare them? Because it's having two different numbers is throwing me off.
It's actually in this example. In this example, basically we have three cases. It's x1. It's between 6 to 8 hours. Second, 3 to 5. And the third one is 2 hours less, right? So when I comparing the sample mean, it's getting smaller and smaller and smaller. What is the average for? My study in the past. exam scores, okay? And students is divided into 3 random groups. The amount of sleep then asked to take the same math exam. Have a sleep enough, right? Because have a sleep 2 hours less, average is only 81.5%. Somebody who slept enoughly, 6 hours to 8 hours, 89. Even you don't have to study math, just sleep. Okay, that is misleading, right? It doesn't make sense. But study the math and sleep enough, then your score is better, right? Yeah. So now, I think it's a typo. I'm sorry. It must be 2. I hate it. It must be the second one, and it must be the third one, right? It's another typo. Yeah. So that is the each estimation, right? But in part A, B, C, yeah, we take the confidence interval for the mean difference, right? It's between this one and this one, between this one and this one, between this one and this one. Right? So that is the homework is tonight, right? And already I posted the homework 19 due Wednesday. So if you have any other question, please email me from number 19, or you can ask me Wednesday. Yeah, we are going to review. We are going to review chapter 7, everything to prepare the exam. Okay. And now here is the quiz number 19. Last name. It's 17. Yeah, you missed 18. When I estimate the two proportions, it must be 275 out of 476. And the second one will be 277 out of 8 or 4. Then now I have, let me see, 275 over 0.58. If you got 3 decimal places, yeah, there is no problem. It must be 0.578, right? Yeah. So, or 0.578. And the other one is a 277 over. I have a 0.34 or 0.345. Yep, the either one will be good. Then now, let me take the 0.58 minus 0.34 plus and minus. Anybody who take the z-score at 98% from the t-table? The z-second? 2.3, say again? 66? Anybody who got the z?
326.
Oh, 326. 2.326. Did you get it? Yeah, it's a times. Right now, then it's a 0.58, 42 divided by 476. And the other one will be 0.34, 66, 804. Am I right? Now then, here's a 2.326 times square root of, right? And this one will be 0.58 minus 0.82. It's a 0.24 plus and minus the E. What is your total? You know? Oh. Yeah. Yes.
So all this together, I just typing it all.
Why don't you try one more time?
Just to avoid rounding.
If we have a similar one, then just give us email me.
Did you get that number wrong? I think that. I also didn't get 3 numbers for the key.